Hello, students. This is Shakil, and I welcome you all in Physics Free Learning channel. And today we're going to discuss a very important topic from IGCSE Physics, that is light waves. Okay, first of all, we have to look on the syllabus specification, and this syllabus specification is for IGCSE and GCE Physics, and it can be used for Edexcel as well. Okay, firstly, in the light, we'll be looking upon reflection of light, some laws related to it, and then the image formed by the plane mirror. Then second topic will be refraction of light, and we'll be looking upon some experiments related to refraction of light, and then along with that, critical angle, total internal reflection, and we will look upon the refractive index as well, how to find that using different equations. And then later we will discuss dispersion of light. That's a very beautiful phenomena that we observe in everyday life. That's like the rainbow formation. Dispersion means splitting of white light into its component colors. Okay, so what is reflection of light? As you can see, this is a beautiful scenery in which water is there, and some colorful buildings are there, and you can see their image. The image of the buildings is formed in the water. So this image of building formed in the water is due to the process of reflection of light. Okay, so what is reflection? Reflection is basically the bouncing back of light after hitting a surface in its way. So there is a law that governs this reflection. So this law states that the angle of incidence is equal to angle of reflection. Suppose this is a mirror and this is a normal line, and remember, this normal line is always perpendicular to the surface, and we use this normal line to measure the angles. Okay, let's say this is the incident light, and its angle is I, and then this is the reflected light and its angle is R. So both the angles are always measured from the normal, and both the angles are always equal to each other. So we will say that this angle of incidence is always equal to angle of reflection. Okay, the next thing is the image formed by a plane mirror. Let's say this is the plane mirror, and this is the object, which is in the shape of a letter L. And let's say light is coming from the object towards the mirror, and then we draw a normal on it. And then this is the reflected light. And well, this is another light from the same point, and the second normal, and this is the second reflected light. Okay, so both of these are the normals. If we brought back these reflected lights behind the mirror, then these lines are seen to be intersecting at one common point. At that point, the image of the object is going to be formed. So the image produced by the plane mirrors having the following properties. Number one, the image is always of the same size as the object. The image is always at the same distance behind the mirror as the distance of object is from the front of the mirror. So this is object image and distance, and this is the image distance. Both should be equal. And then it is upright. Upright means same way up as the object. And then it is lateral inversion. Let's say it is known as left-right inversion or back to front inversion. And then it is a virtual image. Virtual image is the one which cannot be plotted on the screen. You can just view it. Okay, so what are the virtual images? Virtual images are the one which are formed when light rays appear to come from a point that is not actually in front of you, and the virtual image cannot be casted onto a screen. On the other way, the image formed by the projector is the real image, because a projector actually projects image on the screen. So based on our discussion, using these word selection, you have to fill these blanks. So you can pause the video and you can look for the words, and then you can play back the video again to see the answers. So the law of reflection states that the angle of reflection is always equal to the angle of incidence. Both angles are measured relative to the normal, a line that is 90-degree angle to the reflecting surface at the point of reflection. A plane mirror forms a virtual image, which is unlike a real image in that it cannot be casted on a screen. The image in the plane mirror is also the same size and the same way up as the object is. Okay, now we have to look for the refraction. What is refraction? You can see two everyday phenomena happening over there. In the first, you can see the spoon is in the water, and you can see the outer part is this is in air, and this is again in the air, but this part is in the water. So this is in the water. So you can see that the steel spoon is in different parts. It's broken down. Well, this is in air, and this is in glass, and this is actually in glass and the water. So why these three things, like why there are three different sections? This is because of the refraction. Again, you can see here, the light is coming from here. It seems to be bending and then again bending. So what is refraction? Refraction is the bending of light or a wave uh, when it changes its medium. And we can also define it as refraction is the change in speed of light due to change in its medium. Okay, so now refraction occurs when a wave changes speed as it passes from one region to another. So the speed usually changes, the speed change usually causes the wave to change direction. So this is really important thing. Okay, so you can see that the water waves, the top diagram is from the ripple tank. You can see the ripple, the wave fronts. You can see that these wave fronts are uh, moving to this direction, and these white lines are the wave fronts, and the distance between every two wave front is equal to lambda. And let's say this is the barrier, and here is the deep region, and here is the shallow region. So you can see that when water waves are going from deep to shallow region, the waves are getting closer to each other. You can see from here, the waves are getting closer. The distance between two wave fronts is decreasing. So, and they are getting slower as well, because shallow, as for slower, and as for shorter. So it means that whenever water waves go from deep to shallow, their speed decreases and their wavelength also decreases. So this process is known as refraction, right? Okay. So the refraction also happens with the light, as you know that when light passes from air to water or from air to glass, of course, its speed will decrease, and its wavelength will also decrease. Now we have to look for the simple experiment for the refraction. Suppose we have a glass block and a ray box, and then there are two normals at the two air glass boundaries, like this is air, this is glass, and this is air again. This is your normal one, and this is your normal two. Okay, so what we do is, so imagine that this ray box was initially over here. At time 0, it was over here. And when it transmitted light, it goes over there, and it straight away, it moves up. So whenever light is having angle of incidence 0, its refraction angle is also 0, and there is no bending at all. So if light is traveling at 90 degrees to the surface or along the normal, there is no bending. And then you keep changing the angle of incidence. So you can see that the angle of refraction also changes. But one thing you can notice from here is that angle of incidence is always bigger than angle of refraction. Why? Because angle in less denser medium is always bigger. So this is like the rare medium, and this angle is in the dense medium. So it means that when light travels from less dense to dense medium, it bends towards the normal and the angle decreases. Okay. So increasing the angle of incidence, of course, increases the deviation. Okay, now we have to look for refraction of light at a plane surface. So the first thing is less dense to more dense medium, let's say from air to glass. So let's say light, this is the incident light, and this is the angle of incidence from the normal. And when light is going from air to glass, it is bending towards the normal, as the original path of light was this. This was its original path. And as the light travels from air to glass, it bends towards the normal, and angle decreases, speed decreases as well. So light bends towards the normal, and the angle of refraction is less than angle of incidence. So you need to remember this. Whenever light travels from less dense to dense medium, it bends towards normal, its speed decreases, its wavelength decreases as well, and angle of refraction in dense medium is less than angle of incidence in less dense medium. Okay, now we have to look for the second when the light is traveling from dense to rare medium, let's say from water to air. So let's say light is starting from dense medium, which is water, and going into air. So you can see clearly that the angle is greater. It means that this was the original path of the light, the dotted line. This was the original track, original path. You can see that the light bends away from the normal. It means whenever light waves go from dense to less dense, they move away, they speed up, and their wavelength also increases. And of course, angle of refraction is also greater. Okay, why a pool appears shallower? Sometimes it happens that, let's say this is the water and an object is placed at the pool, and it seems that the object is closer to you. Like you cannot judge the original depth of the pool. And this is because of the refraction. So let's say one ray of light is coming from the object. This is the second ray. And of course, now as light is going from water to air, so we have to draw the normals. So these are the normals. And then, the light is going from water to air. So it has to move away from the normal. It has to move away from the normal. So see, it's moving away from the normal because the original path was this one and this one. So now they are moving away. And then when the observer will observe that, it seems to him that these two lights, blue and red, are coming from one point, and that point is, of course, way above the original point. So that's why the pool appears to be shallower than it is. Okay, you have to complete the paths of the red light. You can do it yourself. Let's say for first, it's from air to glass. Over here, you have to draw a normal. And you can see that this is the original path. And of course, when light goes from less dense to dense, it should be moving towards the normal. See, it's moving towards the normal. Similarly, over here, you have to draw a normal. And this is the original path, and light must be bending towards the normal. Okay, it bends towards the normal, and same is the case from here. Okay, let's look at the C. You have to carefully draw the normal. Remember, normal lines mean it is perpendicular to the surface. Okay, so this is angle of incidence, and of course it is bending towards the normal. And then over here, you have to see that it should be moving away from the normal. And similarly for D, for E, there is no change, because whenever light hits perpendicular to the surface, there is no deviation at all. Okay, the refraction equation. When a light passes from one medium to another, we use this equation, n equals sine I over sine R, like this. When the light is traveling from air to glass, this is the normal angle of incidence and angle of refraction. So that's it. But this is used when light is traveling from rare to dense medium. Okay, so the next equation is, again, the experiment to find the refractive index of the medium. Well, you have to set up the apparatus as shown in the figure. And then you have to draw the incidence angle of 30 degree, and you'll trace the light track. Then you measure R, and then you calculate refractive index using n equals sine I by sine r. So that's quite easy, and you can repeat that for any angle of incidence for the incident light between 10 and 80 degree, and then you can take the average value that will give you the accurate value for refractive index of the glass block. Okay, now this is the question for you to try. You have to calculate the refractive index when the light passes from air to glass. So like you have to find refractive index when the light passes from air to glass, like less dense to dense. The angle of incidence is 30 degree and angle of refraction is 19 degrees. So see, it's n equals sine I by sine r, putting the values, and make sure that your calculator should be in degree mode while doing this. There are 3 modes in your calculator. The first one is degree, then radian, and then gradient. Make sure it is set at degree. Okay, so refractive index is 1.53. So calculate the angle of refraction now. Like you have to find angle of refraction when light passes from air to perspex, again from less dense to dense. The angle of incidence is 50 and the refractive index is given. So you'll be using the same equation, but this time you'll first work out for value of sine r, which happens to be 0.511. Then you have to take sine to the other side, so it is sine inverse 0.511, and you can take sine inverse from the calculator by pressing the shift button and then the sine button and then putting the value. You can get the answer. Okay, so I'll suggest you to do this question yourself. Pause the video, solve the question, and then play the video again to see the solution. Okay, again, what you have to do is you have to calculate this, and remember, when light goes from rare to dense medium, so you use the formula n equals sine I by sine r. But when light goes from dense to rare medium, then you use formula n equal sine r by sine I. So now you should be pausing the video and solve all of them, and then play the video to check the answers. I hope everyone got the correct answers. Okay, now let's look upon dispersion. Dispersion is a beautiful phenomena, and it is a phenomena when a light is splitted into its component colors. We usually use a glass prism to do the dispersion, but there are many other things as well in the nature, like the water drops, the air, sometimes also disperse the light. Okay. So, the main reason for dispersion is because the refractive index of both the mediums in between which light is traveling is different. So that causes light to split. So while it has the greatest refractive index and therefore deviates the most, and red has the lowest, so it deviates the least. So let's say this is the prism and white light is coming over here, and then it splits, and then further it splits. So this is the red color: red, orange, yellow, green, blue, indigo, violet. So this is Roic wave colors, 7 colors, and red deviates the least because let's say this is the original light path. So it means as red is the closest, so it means red bends the least. And why red bends the least? Because its wavelength is longest. Its wavelength is longest. That's why it deviates the least. Okay, pick these words. Refraction occurs when a wave changes speed as it crosses the boundary between the regions. The direction of the wave also usually changes. Light rays deviate towards the normal when they pass from less dense air to more dense perspex. The greater the angle of incidence, the greater is the angle of the deviation. Different colors of light deviate by different amounts. Violet deviates the most. A prism can be used to split the colors of white light into a spectrum. This is called dispersion. Okay, now let's go to total internal reflection. It is the process um, uh, which happens in the dense medium when light is reflected back inside the dense medium. So, total internal reflection to happen, two conditions must be satisfied. Light is incident on the boundary between optical dense to less dense medium. Let's say light should be traveling from dense medium to less dense medium. And then the angle of incidence should be greater than the critical angle. So these are the two conditions for total internal reflection to happen. Okay, so you can see clearly over here that angle, if the angle of incidence is less than critical angle, then the refraction is going to happen, like light is going this way. But if the angle of incidence is more than the critical angle, then what's going to happen is light is going to refract inwards. So that's how total internal reflection is executed. So angle of incidence greater than the critical angle. If the angle of incidence is greater than critical angle, then no refraction at all, and then total internal reflection happens over here. Okay, so what's the critical angle? Critical angle is the angle of incidence in the denser medium for which refracted angle is 90. So you can look over here that this is the incidence angle, and you can see that the refracted angle over here is 90 degree, right? So that angle of incidence is known as critical angle. And the formula is n equal 1 over sine c. Actually, the formula is n equal sine r over sine c. Why we use this? Because light is going from dense to rare, right? Dense to rare medium. Now you can see that the angle of incidence is critical angle and angle of refraction is 90 degree. So just put the values. So n is sine 90 over sine I. So sine 90 is 1. So it is, and for incidence angle, we are going to write sine I. So that's why we can say n is 1 over sine C, where n is the refractive index and C is the critical angle. Okay. So now there's a question, and we have to use this equation, n equal 1 over sine C. Remember this formula. So the refractive index is 1.5, and you have to find the critical angle. That's quite simple. Just do that, and you got the answer. Again, the critical angle of water, then the refractive index is 1.3. Okay, just do the maths, and you got the answer. Okay, again, calculate the maximum refractive index of a medium of light. If it is to escape into the water, refractive index is 1.3 at all angles below 30. So n is 1 over sine c. So sine c is 1 over n. So sine 30 is sine 30 is 1.3 over n, and that's how you got the refractive index. Okay, uses of total internal reflection. First is it is used in the periscopes. So you can see that this is a ship, and light from it is coming, and it is not bending over here because it's falling at 90 degree. And then of course it is going to bend inward, and total internal reflection is going to happen over here. Again, it is falling at 90 degree, again at 90 degree to the next prism, and then total internal reflection again happening over here. So that's how someone in the submarine can see the objects on the sea level. So like this is a rectangular prism, and now the reflectors. Okay, so the reflectors are actually the same thing as the prism. So when light falls on their bigger surface perpendicularly, no reflection, but then of course total internal reflection happens over there, and again total internal reflection happens over there, and light gets back. Usually this is installed in the headlights of the cars to increase the amount of the light. Yeah, and in the bicycle rear reflectors as well. Okay, then optic fiber. Optic fiber is a fiber consists of a glass and it is used to transfer the data. There are two types of glass. The core is usually of the thick glass, so that is the dense medium, and then the cladding, the outer side is of the less dense glass, so that is considered as the less dense medium. And then what happen is that when light goes in the dense glass, it is set at such an angle that angle of incidence should be greater than the critical angle, and it is reflected inside. So the data is transferred in the optic fiber in the form of light or infrared rays, and total internal reflection happens in that, and that carries the data at a very high speed. And optical fiber data transmission is very useful because it by this you can transfer the data at very large at in very large amounts and at very fast speed as well, and there are no chances of hacking the signals as well, or there are no chances of signal loss as well. So the optic fiber communication, as I told you that actually visible light or infrared lights are used, and light cannot escape from the fiber and it is continuously reflected inward. Let's say this is the incident light and total internal reflection is happening at all the places inside the fiber. That's how data is being transferred. So compared with them, and we have to look upon its advantages. Like what are the advantages if you transfer data through light and optic fiber over the microwaves or radio waves? Well, they can carry more information, and then is more secure, and then the fastest broadband uses optic fibers. Okay, the endoscope is the medical use of the optic fiber. Well, it's actually there are two fibers into one fiber. The light is going into the patient's body through a pipe, and the second fiber is connected to camera that captures the inside the image of the organs. Let's say this is actually the internal view of the stomach of a patient. Okay, next is the diffraction of light. Diffraction is the spreading of waves after passing through a gap or around an obstacle. So you can see clearly over here, diffraction is happening. The plane waves are coming from here, and you can see that the diffraction is happening over there. So actually, this was the gap through which light wave, water waves passes, and they bend. Same as with the razor blade. You can see the light, the water waves are bending. So, well, diffraction becomes more visible. Well, this is actually the diffraction. Two different diagrams are there. You can see that this is the wavelength and this is the wavelength. You can see over there that the gap width is more, and over here you can see that the gap width is less. So it means for good diffraction or good bending, the gap width should be at least equal to wavelength, or gap width should be more. Should be less. Should be less than the wavelength. So gap width should be less than the wavelength, or it should be equal to the wavelength. Then more diffraction will be there, like the more bending will be there, like in this case. And when it happens that gap width is more than wavelength, then less bending is there. So this is diagram 1, and this is diagram 2. Okay, now some important definitions and equations. Reflection is the process of bouncing back of light after hitting a shiny surface, and during reflection, the speed, wavelength, and frequency remains unchanged. Refraction is the process of change in speed of wave due to change in medium, and during refraction, speed remains unchanged, frequency remain unchanged, but speed and wavelength changes. Well, how they change? They change according to the waves. Let's say if the water waves are there and water waves go from deep to shallow, so speed and wavelength decreases. Speed and wavelength decreases. And if they go from shallow to deep, speed and wavelength increases, frequency remains unchanged. For electromagnetic waves like light and heat, when light goes from rare to dense, speed and wavelength decreases, and from dense to rare, speed and wavelength increases. Frequency remains unchanged. Well, diffraction is the process of spreading of light after passing through a slit, and there is no change in speed, frequency, or wavelength. Dispersion is the process of splitting of light into its component colors. Like white light consists of red, orange, yellow, green, blue, indigo, and violet. And red is having the longest wavelength, and violet is having the shortest. So this is written in terms of decreasing wavelength. And as you know that wavelength and frequency are inversely proportional because all the colors have same speed, which is 3 into 10 power 8 per second. So that's why wavelength and frequency are inversely proportional to each other. Total internal reflection is the process of reflection of light inside a denser transparent medium. Critical angle is the angle of incidence in dense medium, for which refracted angle in less dense medium is 90 degree, and refractive index is the ratio of sine I to sine R, or you can say it is the ratio of speed of light in vacuum to speed of light in that medium. So that's it, students. I hope this quick revision must be very useful for you. I will suggest you to play back the video again and again to look at the points very carefully, because all these things are very, very important from the exam perspective. So take care, everyone. And soon I will upload the next video about light, which is lenses in light.